Hi, I'm Eric Prideaux, editor of Wind Power Intelligence, the market research unit of Wind Power Monthly. I'm delighted to be joined today by Ruben Bake, General Manager and Vice President of Power Climber Wind. And off the line right now is Ben Faulkner, Director at Renewable Advice Limited. He'll be joining us later in the discussion. Ruben Bake has an engineering background. He's worked in North America and Europe in the wind industry. He's been working in blades and access equipment to turbines for about 6 or 7 years. Ruben, why don't you tell us a little bit about what your company does and what your involvement with the wind sector has been like?
Absolutely. Our company is called SafeWorks, and Power Climber Wind is a division within SafeWorks. We make all kinds of internal and external access equipment for wind and other industries, and that includes, elevators and other climb assisting equipment that go inside of the tower, for example, as well as the equipment, the platforms you use to maintain your and repair your blades. And then, we're also heavily involved in the construction and other industries with external access equipment.
That's great. Thank you very much, Ruben. And Ben, I'll introduce Ben a little bit further as well. He's again off the line, and he's a mechanical and aeronautics engineer who has worked for a decade with both wind blades and other equipment for several manufacturers. His involvement includes blade production startup and production development through to after-sales service. So today's topic will be about reducing risk at wind farms and boosting productivity during turbine maintenance. It's obviously a huge issue as the wind sector tries to eke out profits in a very difficult economic period of downturn. Ben, why don't we start with you now and ask you to tell us just a bit about how Power Climber Wind, what it's done since you took off and what your experience has been like. You've been around for a long time, and I'm assuming that you're applying experience from perhaps even outside the wind industry. Hello, Ruben, can you?
Yeah, I can hear. Ben is probably mute. He may have to get back in here.
Oh, I'm sorry. You know what? I probably addressed that to the wrong person. I meant to address that to you, Ruben. Yes, I mean, yes, your company has been involved for quite some time, well before even the wind sector was really taking off. I meant to ask you a little bit about what kind of experience you're bringing to the fore.
The company, you mean, or?
Yes, correct. Yes.
Oh. Yeah, well, we've been involved with wind. I'd say at least 15 years or so in various aspects. Like I said, we developed one of the first lifts out there for the towers. One of the first to develop an intelligent climb assisting system, and very recently, actually, a few years ago, developed a pretty new innovative platform that's been used heavily in North America and now in Europe as well.
Right, I see. According to your website, even some other locations as well, hasn't it?
Yeah, we're basically global. I mean, we've got manufacturing facilities in the U.S. and in Europe, but we supply the world.
I see. Thank you. Now, I should inform the listeners that in the minutes ahead, they'll be given an opportunity to vote in a poll aimed at gaining some insight into how you, the listeners, are affected by issues of maintenance, and with a keen eye to the topics that we'll be discussing today. We're also encouraging you to submit questions to both Ruben and hopefully when he comes back, Ben, to find out as much to basically glean their intelligence as much as possible. And we'll get to as many of those questions as we can towards the end of the show. Now, Ruben, you've prepared a presentation here. Why don't we get to that, and why don't you launch into what you prepared to talk to us about today?
Sure. So first of all, thank everybody for attending the webinar. I think that's a great opportunity. I'd like to discuss a little bit with you the safety and productivity side of turbine maintenance work because both are extremely important in our experience. This is a little bit of an agenda here, but I want to make sure that this is an interactive session. So we've got some things we want to talk about, but we're also happy to take questions and to have a conversation or discussion with you. So why don't I start with what choices you have today to do maintenance work, and what people are most commonly using out there. I'd say, the rope access is still used, quite a bit. It's fairly easy. It requires little equipment, but you're limited to one worker, and these workers are typically pretty skilled people, not that easy to come by. But regardless of how skilled, moving up and down the blade is not that easy. So there's some limitations there, and we'll talk about the safety aspect of that as well in a bit here. The other thing that's used quite often is cranes. In fact, I think cranes are used a lot in the industry still. Cranes obviously get you access, as high as 100 meters and above, so that's a good thing. But they're not that easy to mobilize. So you might get into some productivity issues there with the cranes. Particularly in most wind farms are in pretty remote locations, so they're not that easy to get to. And then lift trucks are also used, but it's similar to the cranes. I mean, they're not that easy to mobilize, and then access to some of these remote locations is not always that easy. So I'd say those three methods are used quite commonly. And we're going to talk about a fourth method today, which is the platforms. I think which is gaining in importance, and for obvious reasons, safety, productivity, and so I'd like to talk about that a little bit. So if I go to my next slide, actually, maybe Eric, you want to ask some questions here?
That's right. Thank you, listeners. We'd like you now to weigh in on our first poll question, and that is: have you ever experienced access equipment issues at remote turbines? Have you ever experienced access equipment issues at remote turbines? The answers are A, yes, regularly; B, yes, occasionally; C, no, never; and D, not applicable to yourself. So why don't you vote now, and we will come back and have a chat about the responses that we get from you. Ruben, what kind of experiences have you personally had with this in this area?
Well, obviously, I'll give you one example. We talked about the remote access of these wind farms, and weather is always an issue. I mean, these are windy places with not necessarily the best, sunshine weathers all the time. So getting the equipment in and out, and more than once, I can tell you, we've had experience where we had to move the equipment or, go leave the site and then come back, which is productivity-wise a terrible thing, and really messes up your schedule.
Right, and what kind of answers are you expecting? I don't know if you're able to view the answers yet yourself that have already come in, but what kind of answers are you expecting to see from our listeners? Do you expect there to have been a broad experience with situations, or what's your expectation for the answers?
Well, I mean, I would expect that, hopefully the audience, has experienced, a lot of different situations, whether it's with the access, whether it's with safety. So I'm hoping to get some feedback from the audience maybe on what some of those experiences would have been.
Okay, well, many answers have already come in. We've heard from a fair number of listeners. Thank you very much, listeners, for weighing in. A total of the answers are a bit mixed, actually, but a total of 60% have had at least some access with equipment issues. So that's perhaps not surprising. Only 8% have said that they have never had any experience, and 36% said it is not applicable to themselves, perhaps because of the nature of their involvement in the wind sector. Breaking it down a little bit more minutely, actually, the answers have just changed a little bit now. Just over half have had experience, and it's 30% regular experience, and 22% say they've had occasional experience, for just over half, and 11% have said none. Okay, great. So we're going to go on to the next slide here. Go ahead, Ruben.
Okay, yeah. So let's talk about some of those challenges, that you've got when you go and do some work on a turbine. Starting with safety. I mean, I think I think it's no news really that falls are still one of the leading causes of industry injuries. Particularly the wind industry. And I think one of those causes is access to the blade. If you can't access the blade, well enough or comfortably enough, and you can't do the work in a comfortable position, you're basically putting yourself at risk. So that's clear. I think that's one of the key drivers of safety issues. I think stability is another issue. Obviously, you've got fairly high winds, 10 meters per second and above, and you want your environment to be stable to be able to perform the work. And finally, I believe personally that simplicity to what the equipment that you're working with is the key to success. So simpler is better. The less buttons and the less fancy equipment you've got up there while you're doing the work, the more it allows you to really focus on the work and be safer. Productivity is of course the other thing we'll talk about. As I mentioned earlier, weather is a big issue, and being able to move in and out of a site, for example, is key to your productivity. How quickly you can take your equipment from one place to another one and set up. I mean, time is money, as we all know. Things like cranes are extremely expensive on a per hourly basis. So, you want to be able to be very nimble and flexible to help your productivity. And all that, of course, will impact your costs as well. How many people you use, how much time you spent, getting in and out and doing your job, and the cost of the equipment itself. So those are, in my mind, some of the key challenges that you've got out there and things you got to think about when you do this job, when you do this work. And so I think, Eric, we're on to another question, right?
Yes, we are. Right, but while I cue this up, I'd like to remind our listeners that you are free to start sending in your questions already. If you've heard anything thought-provoking that you'd like to ask, go ahead and ask those questions. Now, the next question we have in line is, thank you. Listeners, have you or any of your peers ever felt unsafe while working on a wind turbine? The answers are A, yes, very unsafe, B, yes, slightly unsafe, C, no, never, and D, not applicable to yourselves. So go ahead and vote now. And while the listeners are voting, Ruben, why don't you tell us what you expect to hear from our audience?
Well, again, I would expect that you people have some experience with safety and maybe feel slightly unsafe in most cases. Right,
and how does this usually manifest itself? I mean, and what are some of the financial risks from this?
Oh, yeah, but I think productivity is going to be one of the big issues there.
All right. Well, it's time to take a look at the votes. Let's see what we have here. Okay. Again, a good number of listeners have voted, and yes, 42% are telling us that they have felt at least slightly unsafe in their work. The other answers are spread among 8%, yes, very unsafe, and 18% no, never. The votes are fluctuating, but about a third have said that that was not applicable to their own business. So very interesting answers indeed there. And Ruben, why don't you carry on with the rest of your presentation?
Yeah, so I already kind of mentioned some of the things that we believe to be key to safety and productivity, and so I want to talk a little bit about the fourth option that we have out there to perform work on a blade, and that is a suspended access platform. And there's different versions out there in the market. We've got one that we call the 360 BAP. BAP stands for Blade Access Platform. And I'll tell you why we think this is a real safe and productive way to do the work. For one thing, it's very easy to access the plate from any angle. And as I mentioned earlier, I mean, the better you can access your work location, the safer you're really going to be. If you think about, for example, an abseiler, one person hanging on a rope there, basically doing work on a portion of the blade. You've got tools to carry. You've got to move up and down the blade. Not easy. And when you've got tools and you're mingling with the rope, in my mind, not safe either. The other one is you want to be in a steady work environment. So a platform really provides that. You've got certain points of contact to the tower and to the blade. So you're basically not moving around at all, which is what you want when you do the work. And again, providing a safe environment. Productivity is the same thing. We talked about being able to get in and out of the location easily and quickly. So you want something that you can assemble very quickly, which is what this does, and I'll get into the details of that in a little bit here. You want something that's very portable. As I mentioned earlier, a crane is not going to be portable, and when you've got a situation, a weather situation, that thing is going to stand there, and the clock is ticking away and costing money. And then, you want to be able to maybe do the work with more than one person. Again, if I compare this to an abseiler, you've got one person. In most cases, people have, two abseilers, having to work and hanging from the ropes. You want to be able to, more people doing the work is better, quite frankly. So in this particular case, you can have three people, walking on the platform and doing the work simultaneously. And then finally, one thing that I didn't talk about is these blades and these turbines come in all shapes and forms. So you want to be able to adjust to that easily. You want to have something that basically fits all turbine types and is configurable to all scopes of work, which is kind of what this platform does. So if I go to the next slide, an example of how important that access is to the blade. You're within an arm's length basically of the blade, which really allows you to work on this from any angle. Any angle you work from, you're within an arm's length of the blade. You're in a very steady environment. You don't have to worry about safety lines being in the way of your tools. All this provides safety and productivity, quite frankly. One other thing that I talked about earlier was the simplicity. Again, I'm a strong believer in simple is better, and the fact that you don't have a lot of buttons and don't have a lot of hydraulics, etc., provide for much simpler, productive and safer environment. And so here's an example where, in our particular case, our platform can be moved basically with a winch, making it real easy to get to where you need to get to. Okay. And then, I also wanted to share with you, how this particular blade moves back and forth. Again, no hydraulics, no complex equipment there. Provides a very steady platform. Productivity. I really want to emphasize the fact that, getting in and out of the site quickly is key. I mean, everybody's counting their money or the time, it takes to set these things up and to do the work. I mean, you got to move from one turbine to the next one very quickly. And so I think having a piece of equipment that allows you to do that is key. This particular platform is a platform that is almost like a Lego, if you can imagine that. It's modular. It's got a very easy proprietary pin system to attach the different components to each other. So you're basically set up within 2 hours, ready to go. And once you've got this thing set up, you can mount it on a trailer basically, and you can take it from one turbine to the next, allowing you to basically get on with the job very, very quickly. As shown here in the next slide, this is an example of where this thing fits in a trailer. Typically, actually, in many cases, we've actually taken this thing to the site, pre-assembled, if you will, in 2 or 3 components, and been able to put it together in less than 2 hours. So very easy to use. This next slide kind of shows you a pictorial of the modularity and what you're able to do with a platform like this. You can take it apart actually, and you can use it for different segments of your turbine as well. So with the same platform, you could actually you can perform work on the tower, or you can perform very specialized work on the blade with a smaller platform if you need to do that. So very nimble, very flexible, quick, easy. I think those are key words that I mentioned earlier.
Right. The order of the questions the questions have reappeared again, and we've already dealt with that, so we can move right along. And
okay.
Just a reminder to our listeners while you're listening in, do feel free to send in those questions. Thank you. Please.
Yeah. What I'd like to do next really is rather than me doing all the talking here and showing off this platform, this is where I'd like to bring in Ben maybe and have him talk about his experience and maybe some of the challenges that he faces. He's actually on the job right now, and hopefully he can hear us and give us a little bit of his input.
I can indeed. Thanks, Ruben. What would you like to know?
Hi, Ben. I should let us remind our listeners that this is Ben Faulkner, Director of Renewable Advice Limited. Your company provides technical advice on blades to the wind industry, and you're actually on site right now. We understand, and yes, we've been listening to Ruben Bake, General Manager of Power Climber Wind, describe his product here, and it'd be very interesting to hear from you. Basically, what the before and after of you're a client of wind power, Power Climber Wind, and what was the situation like before you started using the product, and how has that changed, and what kind of impact has that had on your business?
Well, I have to say, overall, I think it's had a very positive impact. Before we started using Power Climber's suspended platform, we were fairly reliant on MUPES, basically mobile elevated work platforms, which is sort of, if you like, a development of a crane where you no longer have a suspended basket. And generally, the sort of heights we're talking about of turbine or hub heights, sort of 70, 80, and now sort of up to 100 meters here in the UK. And that's quite a challenge, actually, to get a MUPE when you want it to site and to go, and for the duration of the project, because as has been pointed out, weather has a big impact on the work, especially in the UK, because it's such a windy place to live and work. So actually beforehand trying to make sure we had MUPE availability and reasonable pricing, which is still relatively astronomical given the scarcity of MUPEs of 70 meters plus, that generally made working life quite challenging. And since taking on the Power Climber platform, we've actually found that we are in control of the use of it. We can deploy it when we want, and we know it's going to be available for the duration because it's our bit of kit. But it's had a very positive impact both for us in terms of work scheduling, and I guess therefore also our clients, because we're not sort of at the whim of the new operating company.
And can you give us some specifics in terms of, on average, for example, per blade, the number of technicians who would previously have been able to service a blade, and the kind of work they could do, and what the status quo is now with the new access approach?
Yeah, I mean, basically, from a rope access point of view, you're very limited, at least in my opinion, in what you can do. It's generally inspection and very, very minor repairs, because simply you've got a restriction on what you can carry with you or what you can have hung in a bag next to you while you're working. There's also the issue with positioning yourself, being stable, and of course, inevitably trying to handle materials, chemicals, and tools safely, and also having to warranty the work you're doing. When using a MUPE, the platform is much more stable. obviously, as I said, there's the cost implication and the availability of the mute that's an issue, but generally you can get 2 people onto the job. You've got a fairly limited work scope. Maybe the basket on the mute is 3.5 or 4 meters in width, which means you can access one side of the blade at a time. But generally, you can get the work done and get it done fairly efficiently. But because there isn't so much space available on the mute platform, it can actually result in having to make several trips down to the ground to go and get additional materials or to additional tools or whatever. The change by using a suspended platform, it means you've got a significantly larger working space. If you need additional support up there, you can put additional persons. You can have a 3-person team, for example, and you can still have all your tools and all the equipment, and all the materials, the chemicals, the fabrics, and so on. You need to go to undertake the entire repair without having to descend to the ground.
Thank you. Ben Faulkner, Director of Renewable Advice Limited. He's on site right now, sharing his time with us. Thank you very much for that personal experience. Let's hand the baton back to Ruben Bake at Power Climber Wind, and let's hear some more about the specifics, the specs of your of the platform. I understand you have some more information prepared for us.
Well, I'll tell you what. We can talk about that a little bit through the case studies. If it's okay with you, Eric, why don't I've got a bunch of questions that I'm looking at the board here, and maybe would like to field some of those. Is that okay?
Sure, that's fine with us. Let's take a look here.
I'm looking at, for example, first one, what kind of power does this thing? Where do you get the power from to move the platform? And so the answer to that one there is you basically use a generator. You have a generator on site that will be able to lift the platform. Now, I think a follow-up question to that one there was, what happens when the generator fails?
Right.
How do you get up and how do you get down the platform? So the platform is actually maintained by 2 hoists, and the hoists they do have a manual device basically to allow you to safely descent, from your location. Another question that I see up there is, what kind of wind speeds does this thing hold up to? Well, typically, I tell you what. I mean, so the specification of this particular platform is 10 meters per second, and that is without having any tag lines. Now, if you do have tag lines, you can actually increase that to over 12.5 meters per second. That's important. That's an important thing actually to say, because a lot of these platforms actually operate with tag lines, and that means more people and so forth. So in this particular case, that's not necessary, quite frankly. Okay. Well, the last question that I want to answer here before we move on is do you need to have a person? What about the person that's sitting in the nacelle typically? How does that person do any? How can that person do any of the work? Typically, what happens is you do the rigging beforehand. That'll take you, I don't know, an hour or so, and once you do the rigging, basically, all 3 people are able to work on the platform.
Tell me something, Ruben. I understand that I'm assuming that the solution you're describing here is currently only used onshore. Is that the case?
That is the case currently, but it's not so much because it can't be used offshore, but it's more because it's getting the platform set up, on the sea. That's the difficult part, of course, because you got the sea moving up and down. But if you were able to put this thing, to hang it on a turbine, that would be certainly feasible.
Can it be transported via helicopter?
Boy, that's a stretch question. The answer to that one is I haven't seen that, so I don't want to say yes or no to that.
Okay. Ben, Ben Faulkner, do you have any views on some of the points that Ruben has just covered?
In terms of operational wind speeds, yeah, I mean the platform does perform very well, and once you actually locate it around the blade, it's actually pretty stable to work with, and I mean anything up to some serious damages you can basically do with sort of 1 meter per second range, or even more, so 10 to 12. And when we start talking about large laminar repairs, yeah, it gets quite difficult simply because of the the speed of the wind hitting you. But generally speaking, yeah, it makes it very easy to actually undertake a multitude of repairs on a blade at any one time. As for the generator requirements, yeah, there's no usually in the background. So,
yeah.
There've been actually generally no issues with using anything from sort of 10 kVA three-phase generator, which is portable. It need to be in the back of a van or towed or on the trailer with the platform itself. And as for the person in the nacelle, we don't operate with someone in the nacelle. You go out, you rig it. There's maybe call it 45 minutes if you like, and then that person's back down and ready to work. So then you're working as a team on the platform, actually in the air.
Now, a listener has written in to ask whether the tower paint is affected with the moving up and down of the platform.
No, it's not.
It's not affected. Your experience has been that it's not affected.
The platform has there's pneumatic wheels which are very compliant, and they don't actually do any damage to the power.
I see. Thank you. Okay, now we're having a little bit of difficulty hearing the line, but I hope our listeners are able to hear. I am interested to learn more about the economics. In other words, the economic impact on operation and maintenance costs from this, and to receive a bit more of a breakdown in terms of with and without the technology. Can either of you, either from case studies or personal experience, elaborate on that?
Well, we have done economic studies, and certainly offline, I'd be willing to go through that with anybody. But it's actually pretty simple. And the factors are what I talked about earlier. The cost on a per day basis or per hour basis of a crane, for example, or any of those lift trucks is very steep, and I'll ask Ben to maybe attest to that here. But and so the cost of the equipment itself, of course, is a big factor. Now, then the other factor becomes, how quickly are you able to move in and out of the location you have to be at, and so I think those two, you have to put those two together. We think we've got a solution here that, because it's so easy to assemble and everything, allows you to get in and out very quickly. So that, in combination with the investment that you've got, of the equipment itself, makes for a fairly low and very competitive cost per hour. Which is what you care about, in your job. I don't know, Ben. I mean, you've got any? You wanna throw in your 2 cents?
Yeah. I think from our experience, actually, obviously there is a big cost and difficulty getting cranes or routes in place. But actually, one of the biggest costs is the downtime. When you look at wind farms, oddly enough, are put in places that are quite windy. So when you actually have days that you can't use the plant and use the crane or whatever, you still pay full rate for that piece of equipment. That of course gets passed on to the end clients, and they're not always happy about that, especially if it's, as we have this year, one of the work done over 100 euros. So it's very, not quite good, but very good to be able to offer a solution that has insignificant downtime in relation to this sort of the use of the frames.
Ben Faulkner, you've touched on a very interesting point, and one key question that I had actually planned to ask. So thank you for that. I think our listeners are still keen to hear some more details about the product, and in the few remaining minutes, perhaps we could just hear the remaining get the remaining slides from Ruben Bake's presentation. Ruben, why don't you carry on with that?
Well, I just saw a question there that says, is it possible to access all blade versions? Which I think is a very good question. And as we've been experiencing with a lot of our customers, virtually every job is a different job. I mean, you've got different turbine configurations, so you've got to take the rigging into consideration, but also the blade configuration. And so the slide that's up there right now is maybe a very good example of that. This is a Neg Micon, actually, one of the older turbines, if you will, and this blade gets pitched, and as you can see, we needed to adapt this platform and basically change it by 90 degrees to be able to work on this particular blade effectively. So point is, it's again, the modularity helps you adapt to different shapes and forms of the blade, which is what you want and need.
Fantastic, and I'm assuming the hub is also within reach, depending on how you configure it.
Yes, and you can. Yes, that's correct.
Okay, and in terms of future proofing, in terms of adaptability to future unseen configurations of turbines, have you taken into consideration that aspect of the business?
Well, yeah, an example, of course. I mean, we encounter many examples, and a lot of the newer turbines are going to be very tall and with very big blades, and obviously with very big distances from the blade tip to the tower. So we're constantly adapting the platform to be able to work on that kind of blade as well, making the frame longer and different aspects of it, I guess, to be able to configure to those kind of blades.
Great. Well, listen, we are soon going to be running out of time, so I do encourage you to finish your presentation in the time that we've got remaining.
Okay. Well, so I think most of the rest of the presentation is just some case examples that kind of show how a plate like this one here, and especially this one here being so modular, helps you, fits different purposes that you have. This one here is one example of where you basically configure this into a tower access platform, and by the way, you can also configure the angles of the actual platforms there, to fit the size of your tower, if you will. It wraps perfectly around the tower, as you can see in this particular case here. I'll just kind of go through this, a little bit quickly here. This is a similar example, another tower access platform, basically, providing a pretty cost-effective solution. This one here is, if you remember, the slide that kind of shows the different configurations. So this one here is made into what we call a 2-meter blade access platform, which sometimes, sometimes if you have a very specific job and a very quick job, is the perfect solution because you need less people and you can access a specific side of a blade very quickly. And basically get in and out of there in a much faster fashion than you could otherwise. Kind of go through this, again, similar situation here, a 2-meter platform. Actually, those were it as far as examples are concerned. I'd be happy to field a few more questions if you've got some time. Otherwise, I've also basically put in some information here on where we're at. We are going to be at the Houston show here coming up soon, and we'll have a BAP there to demonstrate. In fact, what's kind of neat is we will also have 3M there, the company, the tape company, to help demonstrate with us how you repair a leading edge on a blade. So I welcome everybody to come and see us and maybe have a one-on-one to field some more questions. But in the meantime, if we're not done with time yet, I'd be more than happy to field some more questions.
Thanks, Ruben. Well, I see that you've already answered many of the questions that showed up. And perhaps, do we still have Ben Faulkner on the line?
Yes, I'm still here.
Oh, fantastic! Great. Listen, I do have a question about where we're heading from here, and I think your insight will be very valuable here. in a recent issue of Wind Power Intelligence publication WindStats, we reported on a recent study by the UK Carbon Trust, the UK's Carbon Trust, that talked about how the cost of wind can be reduced, wind energy can be reduced, and basically looking at offshore reductions in cost of up to 20%. Meanwhile, the UK's Department of Energy and Climate Change is working to identify specific ways of reducing levelized cost of offshore wind down to £100 per megawatt hour by 2020. Now, what do you, Ben Faulkner, think are some areas where specifically there are going to be some key challenges in reducing costs in terms of operations and maintenance?
I was going to say exactly that. The operations maintenance costs are, of course, significant because of access issues. I mean, of course, you still got to get people out to the turbines irrespective. But on some of the solutions I've heard of for blade access that are in development or very close to blades, you range from jack-up platforms with roof sort of rooms attached to them. So you've almost got the phenomenal cost of the jack-up platform and then the additional sort of roof part on top of that. So that's at the moment when I assume that's been factored into Department of Energy and Climate Change's calculations. That will have quite a significant impact on the overall cost in terms of keeping it high. So finding smarter solutions where the jack-up platform isn't necessarily required for maintaining blades will of course drive down the overall cost. Which is finding the right way of setting it up because of the additional challenges with, of course, the sea as well, not just the normal wind and general weather issues. But that will certainly help reduce the overall O&M cost. I mean, of course, you can look at it another way and say that the blades have to be more robust from design. But I've been in this industry for 10 years, and we're still seeing some of the same problems now as we were seeing 10 years ago with blades.
And list a couple of those.
Well, I mean, fundamentally, you've got things like bond line issues, so with the adhesive bond between the shear webs and the shells. We've also got actual laminates, sort of interlaminate shear issues, cracks, and for basically could be caused from things like the poor manufacturing process of poor resin diffusion, or if you go back to some of the older blades or some other manufacturers, maybe say Chinese manufacturers that are using wet layup, so that's hand laying the glass fiber and rolling the resin into it. You tend to have more inclusions, more problems actually built into the blade. I mean, fundamentally, blades are handmade. I mean, it's what a 40-meter blade is around about 700 or 800 man hours, and that is all labour. There's very little automation in the process. So that's one of the big issues that actually means you get such variation from blade to blade.
And does having the ability to apply three technicians to a task, to one of the kind of tasks, repair tasks that you're describing here, is this a place where having that ability significantly reduces costs?
Sometimes, yeah. I mean, it does depends purely on the circumstance. I mean, the biggest benefit actually of the suspended platform is being able to have the additional workspace for tools and equipment. I mean, the third person, if the repair job or the particular task is big enough, then of course that person is necessary. But the biggest benefit is being able to have everything you need, and then if you want some extra things just in case you find something that you're not normally or wouldn't normally be expecting, have that all there ready. And there's no you're not working in a cramped environment that you would be, say, in a view for a plane.
Now, Ruben, your company has experience with a kind of across the board with various forms of technology and equipment. How do you see what key challenges in equipment do you see in terms of reducing O&M costs?
Sorry, Eric, I didn't really catch the question completely. What key challenges do I see with equipment?
That's right. And besides a suspended platform, what other challenges in terms of beyond giving access to more than solitary technicians at any given time, for example, or some of the issues that are addressed with the technology that we've been describing today? What are some of the other issues that you foresee being a challenge in terms of cutting O&M costs in the future?
Well, I'm not sure if I'm getting the question correctly, but you know, I think we've tried to address some of the challenges that we see today. Looking forward, I think it's really all about again, making sure you can do this as quickly as possible, making sure you can make it as safe as possible. So I think maybe one of the challenges we can talk about is all of these countries. Europe, every country is different, but you got Europe and you got some of the other, Eastern European countries, for example, are getting more stringent on their safety regulations and that sort of thing. So, I think being able to answer that, with this kind of solution is going to more and more be important. Yeah, that's what I can think of, thinking out loud here, Eric. I actually, while I'm talking, I'm looking at a bunch of other questions that you've got up on the board.
That's right. We have time for about 2 more questions here. So go ahead. Why don't we look at the question? How do you attach the platform rigging to the turbine so the platform can rise and fall?
Right. Yeah. So most turbines, quite frankly, will have already some kind of a rigging setup. And in fact, in our particular case, we've got a lot of those rigging setups already. We know how to do that, and we've got configurations for those. But in most cases, there will be points of rigging up in the turbine, and holes, if you will, to throw the ropes down through. So that's pretty much set up in most cases, and it's fairly easy to do.
Now, one listener is concerned about the safety of this access. This person asks, is it safe?
Well, if I understand the question correctly there, is it once you start pulling it up, how do you pull it up, and is that safe? Basically, if you can imagine this, the platform is hanging on a couple of hoists, and the hoists, are the ones that pull the platform up. So once that's attached, there's no way to move this, other than upward or downward, with the motors. So it is very safe.
And it's stabilized in a way that it cannot tip either laterally or in any different direction, or it can't tip from side to side.
That's correct. I mean, typically what happens is, this is part of the spec. There's a maximum tipping angle, anyways, and this is the way this thing is designed. And so, certainly in itself, it can't tip over. It's not, unsafe. And then,
you're saying it cannot tip over.
It cannot tip over.
Right.
It's just engineering-wise, it's just impossible. I don't want to get into more detail, but that's just the laws of physics, basically. But beyond that, once you're up there, you can always control a degree or two by how you move the platform along the frame.
And we have time for one more question, and the question is the platform available to purchase or hire, and how would a utility get access to the platform, directly or via a third-party O&M provider, for example?
Well, it's absolutely available, and it's typically purchased directly through us. In some cases, we do have some representatives, that we can go through, but it typically goes through us. And I guess on that note, one of the things that I did not put on that last slide there with the booth information is a contact phone. So I don't know if it's possible to type that in there, Eric, or not, but I can certainly read out a contact number to contact us.
Right. Well, I think the contact number will be available on the website. I'm sure that'll be available from the website afterwards. Right now, I cannot see it, but I'm sure that'll be.
Let me just, if it's okay with you, let me just read it real quick. I mean, I think that way, if people have any questions right away, they could go and answer that, because the website, I think, has a general number. This one here is a particular contact point, so it's one of our specialists. And that number, real quickly, would be +32 for Belgium, and then 486-510586.
Right. Ruben, thank you very much. Ruben Bake is General Manager and Vice President of Power Climber Wind, which provides a suspended platform for access to blades and other operations and maintenance purposes for wind turbines. And we've also been joined by Ben Faulkner, Director of Renewable Advice Limited. And his company, he's on site right now on a wind farm, and his company is also involved in providing blade advice and services to the wind industry. Gentlemen, thank you very much. We've reached that time, and I'd like to thank you both for sharing your time with our listeners today. And thanks also to our audience for turning into today's Wind Power Monthly webcast. Your participation has been greatly appreciated, and thank you for your questions. And we ask that you please take a moment now to rate our webcast and let us know how we've done. And be sure to tune in to our next edition. I'm Eric Prideaux, editor of Wind Power Intelligence. Thank you.
Thank you.